back to the kind of Alice and Bob examples of how it all started. And crucially, lots of example-driven documentations. You're just giving examples, copy and paste, change some parameters, and now you're good to go. And the use of existing web pages that are for humans now also becomes for machines. I don't think the two worlds should be separate. They should be, both can coexist. Because if you want to talk about, I don't know, my case, University of Manchester, we have a website. You can just refer to that. We know that as University of Manchester. You don't need to like build an ontology of every university in the world and that kind of thing. But there are registries and so on that can help with that, but I don't have time to cover all of that. So here's an example that I've been working on. So we basically implemented FDO using a system we call Crate. It's basically using off-the-shelf technologies. We're using JSON-LD, we're using schema.org, and just putting it in a system because we want to package research output, not just data, not just spreadsheets and PDFs and so on, but also concepts, organizations and people, licensing, put them together and give a kind of just enough semantic description, and we package that up together. And we're using the standard technologies so it is fairly developer friendly. But because we're building on that linked data framework, it's already extensible. You can add in more if you need to, right? So the particular domains will add custom profiles with more specific things that are not in the common vocabularies. So you can be general and special at the same time. And I think that's important for FDO to learn as well. I'll mention fair signposting. It's a kind of, came up several times yesterday, and I think it's quite important as a kind of bootstrapping thing. How do you get to the fair digital object? So you can ask Herbert more about that. I'm not sure if he's in the room today, but he'll be here later. So fair signposting is basically using existing HTTP link headers. So this is already used by most websites, the link that says, I want this style sheet to appear, and then the design is downloaded on the side. Now you can also link to metadata and so on using that mechanism. I think that's an important way to link the two worlds of human and machine readable. And this looks very much like the first picture about the fair digital object. You have an identifier, you go to some resource, maybe it's a landing page. It's not very good for machines because it's just lots of text, but add in these links and the machine can find all the fair digital object things it needs to get started. The type, more metadata in a more structured format, the download link. I mean, how many of your repositories actually have a machine-readable download link? Most of them don't. So I don't know how we can say we're doing fair data when the machines can't even download the data. So make sure you do that. And if you want to go a bit further, you have loads and loads of links. You can even have more links on the side there. So if you think about what linked data world should learn from the FDO principles, I think because us in the semantic web community and so on, we have been kind of lost in the wilderness for a bit. So we did go a bit overboard with all the ontologies and so on. It can be very complicated. We don't want that, right? We want the simplicity. But there are some good things from the FDO, like persistent identifiers are very important, so that what works today should work tomorrow, right? This is already best practice, but many people are not following it. And so you should be able to click the link and get to more structured data, or maybe just human readable data. Something should be there, right? And the type should always be explicit. If you go to any website, and as you saw 44% already do that, you should know what it is, right? Is it a restaurant or is it a data set, right? And make the linked data active again. How can you wake this up? If there are tools that can process your particular data, you need to link to these tools as well so that it can be opened up. Say Jupyter Notebooks are used a lot for processing. So if you have these kind of resources, they should be linked as well. What about the other way around? Now, this is of course where I think there's a lot more from FDO can learn from linked data, but from good and bad practices that we've been doing over the years, keep it simple, right? We saw yesterday some tendencies to start building lots of new type systems and things like that. Only do it when we need to. That's what we heard from Bob Kahn about strip away things until we have the bare necessities and still do something extra, something that is valuable. Encourage that organic growth. You don't want to force everyone over on one page. You want to do it step by step. So the legacy systems needs to be recognized. They're already there. We have all these systems out there. They're not going to change overnight. Or maybe they can add small things, like the fair signposting, one extra header, add that in. Add the metadata on the side and just point to it. And consumption should be the first principle. If there's no one's going to consume it, there's not really much point in formalizing that knowledge. So you want to think about how things shall be processed, the use cases of how fair digital objects will be used, consumed. That should be driving how you shape them, how you put them out there. And use existing tooling. We have all these tools already out there. Some of them, yeah, they're awkward to use, and you need to learn a lot, and maybe we shouldn't use those. But some of them, you can get started fairly quickly. And establish the best practices and shared vocabularies, so that it can be easy to get going. Examples for everyone. All right, that's it for me, and I don't know if we have any more time for questions, but...
Yeah, we have. Thank you very much. It was very interesting. Are there any questions in the room? I have some. Oh, yes. Yeah, you mentioned that the metadata that was in the first slide representing the Fair Digital Object Framework can be a Fair Digital Object itself. Well, then we have metadata of the metadata of the metadata. It's never ending.
That's a fair point to say like that. So obviously we want to avoid recursion when you don't need to. So the metadata about the metadata, normally you just say it's myself, right? So you don't necessarily need to have a separate metadata object, because otherwise you'll never finish, right? So sometimes you have to terminate. And I think the role of having metadata objects is because you already have existing formats you want to use in their existing form serializations. For instance, DataSite has a quite good schema for the kind of surface level things like authors and license and so on, but it doesn't describe the content of files. Frictionless data can describe the content of files. So you have several layers of metadata which you could represent as separate resources, separate FDOs if you want. I mean, when we do this in our code, we just put them all together, so you don't need to dereference a second persistent identifier, because very seldom will you need that second identifier, because why do you want to talk about the metadata? That's metadata. So I think that solves it. But you can do it if you want to.
Fine. Any other question? Otherwise, I would like to ask. Relation between AeroCrate and the Fair Digital Object Framework. Can you explore this a little bit more?
Okay, so the Fair Digital Object Framework is exploring how to use the linked data platform, which I didn't get to explore here, but that is how you can basically collect up these triples bit by bit as separate resources. So that's already the W3C standard for how you operationally connect to add and query and so on to a set of objects. It doesn't say much about what is inside these objects. Now, so it doesn't say how do you describe the author, the license, and so on. AeroCrate is a way of describing these things, but it's also a way of grouping objects, no matter where you put them. So they could be inside the linked data platform. They could be on a USB stick. They could be on Zenodo. Now we're making a FDO profile of AeroCrate, which is kind of more restrictive. It's saying you want to use persistent identifiers for all of the entries, and it basically formalizes as well, just like I said here, what can linked data learn from FDO. And the linked data platform is one possible way to do it. But I don't think it's necessary, right? Because that's more of an API way to think about it rather than a data way to think about it.
Thank you very much. we have to proceed. Attention to the second speaker, that's Carlos Martinez-Ortiz, and he will speak about how does software fit into the fair digital object landscape.
Yeah, thank you. If I can, yes, that's perfect. Good morning, my name is Carlos Martinez from the Netherlands eScience Center, and I'm talking also on behalf of the FAIR for Research Software Working Group. So this is some work we did together. So I want to start by saying I did my PhD in the UK, and one of the hobbies that I picked up in the UK was watching the Great British Bake Off. So British friends won't let me lie, it's a great show and it's super interesting. For those who are not familiar with the show, basically novice bakers go to this show and they have to bake something. And there's one part of the show that I always found really interesting, which is called the technical challenge, where people are given the same ingredients and they're given a recipe and they're judged on the final product. Okay, so that sounds actually very nice, and it's a nice way of testing bakers' skill as a baker. But sometimes the technical challenges are a little bit underspecified. What do I mean by a little bit underspecified? That the instructions can be something like bake a cake, and that's the instructions that the bakers are given. It's like, okay, yes, what type of cake? With should I use 1 kilo of flour, 2 kilos of flour, 7 kilos of flour? What temperature should I set the oven? So it's a little bit, that's why it's a challenge, because it's underspecified. Yeah. So that's, maybe if you give those instructions to a professional baker, he'll know, oh, sure, okay, no problem, and they can do it from top of their head. If you give me those instructions, I will probably burn the thing. In a similar way, I would like to talk about how do we do science reproducible, right? That's what the FAIR data object framework is for, right? We want to do science that is reusable, reproducible. So this is the great science reproducibility test. We want to take some data, do some processing, and get to the same result that somebody else did. Actually, it's the same thing that the technical challenge. Take the same ingredients, bake the same thing, and you should get to the same end product, and it should look the same as the judge expects, right? But the problem is that if we just give somebody the same data that somebody else used before, and we just say, okay, here is your software, just analyze data. And there's no instructions on, okay, is this a Python 2 script, a Python 3 script? Should this run with a GPU? Should this run in a supercomputer? And all the specification of what type of oven should you use at which temperature. It's the same thing, right? You miss the context. If you don't know how to run this script, if you don't know how to analyze this data, then you cannot reproduce the same experiment unless you are a professional software engineer that already knows how all these things fit together, right? So it's a bit of an exaggeration, but the problem that we face is real. Lots of PhD students are walking to their first year of their PhD, and they're told, okay, you should be able to reproduce somebody else's analysis. Here is the data, here is the software, but there's no instructions of how to install it, how to run it, how to deploy it, and this makes actually the reproducibility of science quite challenging. So where is software used in the scientific process? Actually, with my super simplified scientific process, we have data that we process to analyze results. We use software actually in all parts of this pipeline, right? We use software for collecting data, cleaning data, collating data. We use software for analyzing data, transforming it into different format. And we use data also to verify the results, to publish them, to share them. So software is actually involved in all of these steps of the process. So we should make sure that the software that is supporting all of this research pipeline is also fair. So just as those are the roles that software plays. It's a digital object itself. It's responsible for creating new data objects, and it helps make digital objects available. So it helps creating them, transforming them, and sharing them. So why are the FAIR principles for research software needed? Well, we already have FAIR principles, right? Why do we need FAIR principles specifically for software? Well, as a computer scientist, I think always in terms of zeros and ones, and just putting zeros and ones in a hard drive. That's your software that you're archiving, and then you run it. Sure, from the computer science perspective, that makes a lot of sense. But actually, at the same time, software is not exactly a type of data, because it requires its context. If I have my software, my Python script that I used, I still need to understand the context, which version of Python, which operating system, to be able to run it. So that's why we, at the FAIR for Research Software Working Group, worked in extending these the FAIR principles to make them available or applicable to software. So software is not data, in a way. So the FAIR for Research Software Working Group was a joint working group between RDA, Force 11, and Research Software Alliance, and we started working in like 2019. We've been working for a couple of years in developing these FAIR for Research Software principles. We had an extensive community consultation where people contributed to the principles and had interesting discussions whether these were suitable, they were going too far, no, but we should do it this way, should do it that way. But in the end, we got to a final version, which was published as an RDA recommendation. And actually, there was also a Nature Scientific Data paper that came out 2 weeks ago, I think. So they are something that is available, and it's important. So what are the main differences that we see between software and normal data? Is that software usually has specific properties, like software is executable, it has a composite nature, meaning you have dependencies to other software packages. It has its own development practices, and it continues to evolve, right? You have the different versions of Python, so Python continues to evolve. You have a packaging and distribution technologies that are already used for software, right? So Arrowcrate, for example, is a way to ship software. I don't know, my main programming language is Python, so PyPy, it's also a good way of sharing software, Docker containers. So there's already a lot of existing technologies for this, which we can just leverage to not reinvent wheels, right? Okay, so how does this fit into the FAIR digital object landscape? From my point of view, software is a key ingredient to the whole landscape. And it's the software that we use should also adhere to these software principles. But I think that there needs to be a little bit more specification, a little bit more detail in how this is done and how we make the software that is used for supporting this process reusable. So I think that there should be more consideration and more collaboration in how do we make software also fair within this framework. This is not just about the data, but also about the software that helps us handle this data. So thank you very much for your attention.
Brilliant. You didn't take the whole 10 minutes, so we have more time to ask. Yes, please. I think you should go.
Hi, Carlos. Thank you for the talk. Just disclaimer, I'm part of the group that work on this as well. And my question is related to FDO. We have talked about how typing is important for FDO. I don't know if you will have the answer or someone else in the audience. What sort of types do you see for software? Because they have talked about PDFs, XML. Those are for data, but what sort of types do you see for software?
Well, so that's exactly the problem, right? Or not problem, the challenge. That there's already many types defined for data, but there's types also required for software. And I think that they're okay. So I think in my mind I see two main types of software that would be binary and would be scripts. So interpreted software or executable software. I think that would be, I would start there, and then you could also even go further in subtyping these, right? Because you also have, I don't know, within the scripts, you would also have things like notebooks that have like already a very well-defined environment in which they run, and not all. So I think then there you might be able to create many subtypes of software, maybe per programming language, and so yeah, I don't know, but then I'm not the expert on types.
So I wonder if there isn't already an ontology of these different types. So do you know anything about? You should know, no? Sorry. So I have not really investigated this, but I'm sure that there is an ontology about this already. Yeah, you built one, right? Yeah.
No, I had a question actually.
Yeah, in fact, then come, because it's not long enough, I think.
No, my question is mostly related. How do you envisage where we should put the burden in this race, in this travel to fair software? Like researchers are usually software savvy, more and more, I have to say, but still getting into all the details on handling types and handling notebooks, even knowing how to set up a binder repository, for instance, is something that they need to learn.
Yeah.
So, and there are tools out there that can collect all this information within container or not environment. So, how do you envisage that we should actually focus our effort on the tooling or on evangelizing the research community in applying the practices?
That's a very good question, and I think that I think it's both, right? Because for data curation, you have people who are specialized in the data formats, but also people who are more specialized in the data curation, making the data available in a fair way. So I know in the Netherlands, most universities have data stewards who help researchers have this knowledge specialized in data. I mean, I see a few around the room, so they won't let me lie. And I think that in that sense, researchers are becoming more savvy, and I think researchers should continue to become more aware and that have a better understanding of software and of the tools that they're using to work. But I think that they also need to be supported by research software engineers in the same way that for the data publication process, they are supported by data stewards. I think the research landscape is changing in a way that it's very difficult to be like a one-man band that does everything, and the data and the software and the science. And I think that's where things like these ideas of team science, that you don't have like one person doing everything, but you have a team of experts who are handling different parts of the research process, it's really necessary, because there's really so much expertise that is required for any single result that it's just impossible to do it with one person.
Is there any other question? Please come ahead.
Okay, I will. Oh yeah. So I have a question about this distinction between software and data, because the architecture of the FDO is quite generic, and we have the metadata. And why do you think that we need something special for software? Meaning, isn't the metadata that we have sufficient? Isn't it just about identifying what type of properties we have to define for metadata and continue using it this way? And the second question is, what do you think that the machine should do with the software once it is received? Because yesterday we had this example that computer gets the data and knows what to do with it. So do you foresee that the computer executes the software as well? And that's why you need this typing system? So these are basically three questions.
Yeah. So if I can have my slides back, I can. I think I have a couple of points of why we need. There's specific points, right? There's the executable nature of software, and there's the dependencies. That's something that in my view in the FAIR principles is not addressed. So I think that Leila, correct me if I'm saying something that's not correct. Most of the effort that we had was in the interoperability part, so that the interoperability for data means something slightly different than interoperability for software. And for software, it's important that software has an API so that other software, other tools can call it. And I think that's where most of the difference was in the. No, I thought I had something with the principles themselves, but no. And reusability. So for software, the reusability aspect is actually quite important. And going back to the second or third question, I've lost track. If an agent visits a data object and says, "Oh, there's this software. Where do I run this?" I think that's actually part of where there needs to be extra thought put into this, because if the software that you use actually requires a high performance computing infrastructure to be able to run, then you really need to have access to that infrastructure, right? So if I don't know, I'm going to say an example made up on the spot. If you have some machine learning algorithm that ran on Google infrastructure, and then you want to verify that or rerun it or run a slightly different version of that, and I want to run it on my laptop, then that's just going to be impossible, right? So I think that there needs to be extra thought, that it's not just the research object itself that you say, "Oh yeah, can I have the result, please?" But you need to put some extra thought into, okay, if I need to perform an operation on the object, where is this operation going to be backed up or support or run? And I see Carol approaching to the microphone.
Yeah, I was just going to help you out on remembering what the principles were, Carlos. So the difference is that there's the issue to do with versions and components, because software is made up of multiple objects and libraries and so on. So that's the findability aspect. You need to really understand about identifiers for all the way down. The interoperability focuses more on APIs and standards moving between software. And then from the reusability, it's really thinking about not just reusability, i.e. can I fork this software, can I use it in and reuse it as one would expect, but is it usable? And I think that's what you're speaking to about the portability and aspect to it. Just to tell you that, yeah, I have read them.
Yeah, thanks, Carol. And you were also involved, so.
So we have, unfortunately, to move to the next speaker, Felix Bach, who will talk about research, data research repository developments. Radar, is that the repository you are talking?
Yeah. Exactly, Barbara. So I will try it like this. So first of all, thanks for having me today here. Yes, so this is not close enough, right? Is it okay like that? Yes. Okay. So let's start. Let me first give an outline of what I want to show you. So I'll introduce Radar, which is a generic advanced research data repository. I go a bit into the details of its functions, its concepts, and how Radar is used and applied in the German national research data infrastructure that is set up in Germany right now, short NFDI. I will explain the concept of Radar for storing data packages, and I'll show the current developments, and then I'll try to point out how we could close the gaps for an implementation of the FAIR digital object framework here. So the acronym Radar is short for Research Data Repository, and Radar was developed in a project together with many partners from 2013 until 2016. And it was funded by the DFG, the German Research Foundation. It is cross-disciplinary, and it's meant for the archival and for the publication of research data, and is hosted at FIZ Karlsruhe, where I'm working. It's hosted there since 2017 now as a service. It offers two service levels, you could say. One is the data archival, where we have flexible retention period. You can choose between 5, 10 or 15 years. access rights can be set to either be private, shared, or public. So researchers can choose let's say a circle of people that have access. And on the other hand, we have data publication, which includes data archival, of course, but here we have an unlimited retention period. We guarantee 25 years. We offer optional embargoes, which are delayed publications. And this can, for example, be useful in a context where patents play a role and these things. Data side DOIs are used to point to the published data sets, and we provide an interface for peer reviews as well, and users can choose a license. Descriptive metadata is indexed by Radar itself, but also by DataSite, Clarivate, Google, and subject-specific search services as well. And this slide here shows a schematic architecture overview of Radar. We have 3 layers here, which are able to talk to each other over an API, an application programming interface. This allows the Radar management layer in the middle to serve diverse user interfaces on top of it. And you could even create your own one, right? Or reuse Radar in your own infrastructure or something like that. On the lower slide, the Radar backend serves as a management layer with interfaces to the different data centers that are used, because Radar stores 3 redundant copies of each data set at 3 different locations. So one is in Dresden, another one at the KIT campus north, another one at the KIT campus south, and additional data centers can be easily connected. And many institutions are already using Radar, and we get more and more requests by universities and research institutions in Germany. Our cloud offer is, you could call it a paid all-in-one solution. So this makes it really easy to quickly set up an institutional research data repository, which these kinds of institutions like to have now more and more. However, we offer Radar also in other scenarios now. Some institutions want to keep their data at their institutions, so they want to use their own storage systems. We call these installations Radar Local. This is the left branch here in the slide. In the middle, you see another variant which is useful for projects that want to use Radar as a backend and build custom discipline-specific solutions on top of it. Yet another special variant is the offering for the consortia within the NFDI, the National Research Data Infrastructure, that is currently set up in Germany, as I said. And here we offer data publication for NFDI for Chem, the chemistry consortium within the NFDI, in which I'm one of the co-spokespersons leading the task area repositories there. Additionally, we created Radar for Culture for NFDI for Culture, which is dealing with cultural sciences data. And many other consortia are also interested, and these NFDI offerings are rather new, so let's have a closer look at Radar for Chem, just as an example. It is quite similar to Radar Cloud. It provides data publication, an unlimited retention period, DOIs, DOI reservation, embargoes, peer reviews, descriptive metadata, licenses for reuse, as well as linking to other digital resources by related identifiers, harvesting of metadata via an OAI PMH interface, single sign-ons, and also metrics and metrics on access and download figures are useful for tracking the impact of the data sets. And what is special for Radar for Chem, and of course for Culture as well, is that we offer only publication here. So no archiving only option is available. but we offer this publication completely free of charge for the researchers, so we try to foster fair data with that. Radar for Chem complements the portfolio of existing subject-specific repositories in chemistry because it allows all types of data and formats, and it is the ideal place for datasets for which no special repository exists yet. Also for interdisciplinary data and for distributed datasets that do not fit into one single existing repository due to the diversity of the data formats. This slide here shows the roles and rights within Radar. And as roles, we have administrators, of course, who manage Radar, a Radar instance on a contract level. They may create several workspaces with dedicated curators. Curators are data providers which are allowed to issue the publication or the archival of datasets, and they can add so-called sub-curators to workspaces which are able to upload and manage data and annotate it with metadata. And when it comes to metadata annotation, this can be done on a dataset level in Radar, but optionally also for individual files and folders. And users can, of course, fill a web-based form, but they can also upload an XML file or use the Radar API to add metadata. And we have integration of ORCID, the Crossref, Funder Registry, RAW for institutions, OpenStreetMap, as well as several ontologies and terminologies. And there are 10 mandatory fields and 13 optional fields in this generic Radar metadata schema. Datasets can have several states. One is temporary, the other is published or archived. And for the archived or final datasets, submission information packages are created, short zip, which are realized as Bagged containers, stored as tar files with the DOI as a name for published datasets. And on the lower slide, side of this slide, you see a current example of this. This is a data folder with subfolders for dataset and metadata. The current developments in Radar include disciplinary metadata management, and users are already able to upload metadata as XML, including the validation against the schema. But creating schemas is still not very user-friendly, so we are just developing the Radar metadata service to allow the convenient creation of custom metadata schemes. And there are metadata input forms for the Radar front end. And we are optimizing the management of big data by minimizing data movements and so on. We want to have single file access for datasets that are containing multiple files, and we are working on versioning as well. So I have two more slides, Barbara, and they are important. There are still a few gaps that need to be closed to be able to implement the FDO framework in Radar, and I would like to see the Digital Object Interface Protocol implemented to allow applications to interact with Radar datasets, which is already possible using the API, right? But not in a standardized way yet. Clients would here be special viewers, for example, or editors and these kinds of things. The Identifier Resolution Protocol, the IRP, is a promising concept for Radar. Currently, Radar DOIs point to HTML landing pages with several download options that you can see on this image at the right side. These pages are nice for humans, of course, but not machine readable, as we have learned, so we need to change that concept a bit. And one possibility, and I just discussed that yesterday with Louis and also with Stian, could be to enrich the landing pages, as we have learned, for example, with machine-readable schema.org annotation or with signpostings or typed links, and include pointers to an identifier record to enable machines to find it. It should provide links to the metadata sections like technical provenance, disciplinary, that are already downloadable in several formats, and you can see these download formats on the right side. And I want to add JSON LD here soon, so it should point. It should also point to other types like the license, for example, right? And this is just a graphical representation of what I just said. So a DOI would identify a URI of a landing page. The landing page should include machine-readable information like an embedded identifier pointing to the digital object and the identifier record and the metadata records. And the rest is just following the FDO framework then. Okay, and I would really like to discuss this with you and see if you see any improvements or what could be possible to increase the fairness of radar.
I have a question because it's really pressing. So I see the linkage that you would like to include, so the F3 principle, so how you link your data to your metadata, but it should also go in the other direction, from the metadata to the that data should be bidirectional. So think about it, I don't know, it's still future, right? And another question is, you were talking about the metadata schema editors, yeah? They should also be able to include the vocabularies, be linked to the terminologies. You are working on that.
Exactly. So this is not an easy task, of course, because there are so many discipline-specific ontologies, and yes, maybe we can have a discussion which is the easiest way to include these many vocabularies. So there are services coming up like one from the TIB that are curating ontologies and terminologies and offer them via an API. So this would be an easy way for a service like Radar to include them.
Yeah, it's really challenging. There is no one entry point for all the terminologies. Please, Stian.
Hi, I'm glad you're using Baggett as well. So I've been involved with that as well, of course. And I wondered if you've thought about capturing the metadata in there, because we've been using it with our crate also for this archiving and so on, so we know things will be there in 20 years' time, and your lovely infrastructures may have sadly run out of funding. And so if you have any thoughts on how to also add the metadata in there, ideally with some identifiers and so on, even if they don't resolve anymore.
Would you like?
That's a really interesting question, because so I told you we are using Baggett as a tar file, which is then archived in several data centers. So the main problem is how to get things out of the tar file or to change things in the tar file. Of course, we also keep the metadata in a database so that we have fast access to it and can change things. But then we have a sync problem, right? So one thing that I would like to have is Baggett as just a folder and not a tar file. So this brings a lot of problems for the archiving services, right? Because many small files in the archive are not a good thing. One tar file is more efficient to read and write and so on. But of course, the metadata are included in the Baggett, so everything. But the problem is, if you press archive or publish, then it's fixed.
We can just allow one more question because we are late.
Okay. Hi, my name's Ray Plan. I'm from NIST, and I operate at our institutional repository. And I wanted to alert you to, talk later about a profile on Baggett that we use that addresses some of those issues. So we will follow up. But my question is actually, have you thought about what things in your repository you want to represent as DOs? So are we just talking about the published data set that you've given a DOI to as being an FDO, or do each of the files within that publication, are they also DOs? What about the metadata? Have you thought about, you know, how you think that should map onto your entities?
That's a good question. So as I said, we have also metadata, or we allow metadata on the level of folders and files as well. So we could point to them individually, but we don't enforce that. And the researchers don't do it right now. They just add metadata on a dataset level and not for individual files. But these should be FDOs as well, right? Or there should be collections of FDOs, or there should at least be some way to point to them.
Felix, unfortunately, I have to stop now because we have to welcome Henrik from Wörden. Please go ahead with your topic.
Thank you. Yeah, my name is Henrik Tom Wörden. I'm CEO and co-founder of IndyScale, a company that provides data management services to research institutes. That's not the right one.
Sorry, that's wrong.
Tom Wörden. And I checked it twice.
No, you are in the.
It seems that he was in the wrong session. So Mark Wörden was in the other session.
Yeah. So, but Henrik is here in this.
Yeah. But he had the wrong session. That's what I want to say.
So what should we do?
You have it on your laptop?
I've got an USB stick, but so are they waiting for me in the other room, or?
I'm not sure.
No.
So
We're here, but you showed
we could do the following. We could.
Close my mouth.
Sorry, we could do the following.
I've got it in USB drive.
We fix this. In the meantime, you hear the next presentation, so we can get your.
Okay.
Yeah. Okay. Because time is rushing, and yeah, I would like to ask Rainer Stotzka and Andreas Pfeil to take over and talk about realizing fair digital objects for the German Helmholtz Association of Research Centers.
Thanks a lot, and moin to everybody. First of all, I'm here just standing as a poor replacement for Thomas Jekal, who should give the presentation. And he's not speaking for himself, he's speaking also for the Helmholtz Metadata Collaboration Platform. And many people contributed to the content here. So for example, Andreas is here. He is one of the experts in the key information profiles. There's Nicholas, there's Jan, and of course Carol. She also contributes to HMC because she's in our scientific advisory board. So, and now? Okay, just a word about the Helmholtz Association. The Helmholtz Association is the association Germany loves to create Vereins associations. And it's a loose association of large-scale research centers. And all of them, 19, I think the number, are individual. So they have their own governance and so on, and they will do their science individually. They are connected via the research fields, and for example, one of the research fields is energy, other one is earth and environment, and so on. But since they are all individual, also research data management is very individual in these centers, but there are commonalities. And for that reason, we have created the Helmholtz Metadata Collaboration Platform. It's a platform to create commonalities and to spread them. So it facilitates the discovery, access, and machine readability of research data. So now with the Fair Digital Objects, I'm going into the direction of looking into research data and especially of metadata. And we have, of course, support units for each of the research fields, for example, for health, information, energy, matter, and so on. But what I would like to talk about is this shiny, very small thing here in the middle, which are the Fair Data Commons. If we do research data management and fair digital objects, we are looking for commonalities. And especially here we see the potential of fair digital objects to be worked with. So, since we are here, I would like to point out research that has been done and a presentation of Christine in 2014 at the Amsterdam RDA plenary. And here she said, data everywhere, nor any drop to drink. And it's about this famous four-letter F word, which has been introduced at the Amsterdam plenary, which is fair. And what Thomas did now is something extraordinary. He looked into read3 data. read3 data, which is a collection of all the repositories and data collections, and he analyzed them concerning into the direction of fair. So, looking at the F, findability, we see that many of these repositories and data collections are using standard identifiers, but some of them, 160 nearly, don't use standard identifiers. Interoperability, at least semantic interoperability, many of them use standard, but the variety of metadata schemas for them, some are custom. Looking into the interoperability, looking at the I forgot that one, because this one is somehow, this is accessibility. We have the common interfaces, REST, OAI, PMH, and so on, but also we have here nearly 30 repositories which are accessed via FTP. Wow, that's really something. The R, this really works, and so on. Here we have license and so on. But if we look at the technical interoperability, then it's getting somehow interesting, because what is inside? And if we ask the repositories, what kind of software are you using? So, and are these systems which you are providing, which provide your data, are they maintainable? We find that more than 300 of them use some repository software. They don't know exactly what it is, how it is, and it's maybe something very priority, because these are not the standard repositories. So, and if you would like now to make them fit for fair digital objects, and you ask each of them, please adapt a certain kind of code, an API, to be fit for fair digital objects, this will be somehow difficult. So now I have to look into my slides, into my notes. Yeah, so we needed a kind of a different approach here. And this is one of the reasons why we see the fair digital objects. It's a fine concept, and we would like to enable these concepts. And like Stian already pointed out, when we have something, if we have something already reliable, available, methods and tools and software, we should use it. So the basis of the fair digital objects we are using for us are handle PIDs. So we have here a handle PID, and the handle PID points to a kernel information record. This is a recommendation of RDA, and we are doing that. And if you look into the information record, we see some important information, some information about the kernel information profile, and very important, the digital object type. And here we are talking about the type scanning electron microscopy data. And of course, it points to the data itself and many other parts in here. So it's a kind of a specification of a concept, what we have here. And what we are doing, that when you see it here with the scanning electron microscopy, we need to put it into practice. So it must go hand in hand, the specification, implementation, and putting it into practice. So, and this is more or less it. But the reality looks different. If you look into the information record, it looks different, because we have a strong typing in here. A strong typing means that even my entries are being typed. They are PIDs. And what are we losing? We are losing the readability for humans. It's now machine readable, but not longer human readable. So we need a couple of tools to make it run. On one hand, we need a kind of a fair digital object laboratory, which allows us to create these objects and to interpret these objects. One of them is the typed PID maker, also adapted from RDA somehow, which creates fair digital objects and is able to validate them automatically. Then, if you look at this kind of a record, it's nasty, isn't it? So we need a visualization for that to make it, again, humanly readable. And one part is the FDO scope. Just here, we just have the logo. You will get some information about that later. And now, what is important, we have this, this information record. We need to agree on how to shape this information record for certain applications. And this is something we did in Helmholtz. Sorry? So, we design a fair digital object. For the fair digital object, the kernel information profile, and it consists of 15 attributes. And some of the attributes are here, and some important attributes are here, has metadata, pointing to a different location, and is metadata for a metadata object. So these are important things. And what you also see, creating such a kind of a profile is simple. Difficult is creating consensus over a variety of research fields. So, very quickly now going about one, we are applying that. So in Helmholtz we have, in Zenodo we have lots of data sets. And these data sets can be created more or less and converted more or less automatically into this kind of fair digital object shape. So the information record will be filled automatically. This is one part. This helps us to create and to connect also to legacy data collections. Coming to the result, so we agreed on, and we have the consensus among the research fields that we can use a common information profile for these fair digital objects in the Helmholtz Association. We have shown that it is possible to create to extend the RDA recommendations in here. We are based on that, and we are able to apply it to legacy data. So we are able to create thousands of fair digital objects now out of that. And just I want to point out, here you see a QR code. If you scan this QR code, you also have it in your notes. Here you can look directly at such a fair digital object and with the FDO scope, and you can visualize the content. Thank you for your attention.
Thank you very much, Rainer. Any questions in the room? Yes.
Maybe one question. So, Rainer, in one of your first slides, you showed the type, and you had some category there. So I assume for the Helmholtz or so, you're also defining these types in a kind of type registry or whatever you use here. So they are defined and so that you can link them with operations and so forth, so that machines can do something with it.
Of course, here we are using the GWGD data type registry, originally built by via Corda and so on. This is something which will be reused. Defining types is a challenge, especially complex types. And this is something we have to discuss here in the forum, and in the forum. How can we make it simple to define these types?
Please.
So the Helmholtz has an extensive range of organizations, ranging from biosciences and medicine through to space and particle physics. So the types there, how do you envisage Helmholtz being able to manage types over such a range in a common space?
You find me speechless. Because this really needs some organizations. This is something we are currently also discussing. We are currently doing it for a couple of examples, defining the types, like for example here for the scanning electron microscopy types and so on, and this works well. Most of it currently is legacy data, And with the legacy data, we have a couple of types. They are just registered, but they are not yet machine actionable based on the DTR. So, for example, you are aware of that we are also RO crates play an important role, and they build an own type in that, and then they can refer to that. And I don't know exactly how it works. Andreas, maybe you can help.
Here he is. Yeah, yeah.
But we don't have time to go into this.
Okay, the question is how to get now to the machine actionability of the types. And this is really a challenge. Sorry that I couldn't answer this question directly. And now I'm giving back to the moderation.
I'm sorry to be so strict, but we are over the time already. So please go ahead, Henrik.
Thank you. Okay, yeah, that's the right one and the presenter.
I've stolen it.
Okay, thanks. Well, I already introduced myself. Henrik from Wörden, CEO and co-founder of IndyScale. And let me give you a brief introduction of what we are doing. So I mentioned before, we provide research data management services to research institutes. And the main aspect is a research data management software that we are developing. It started as a research project at the Max Planck Institute for Dynamics and Self-Organization in Göttingen around 2011. Was later published as open source software, and since 2019 we are providing services for this open source software. So if a feature needs implemented, we can do this, or if there's support needed, that's what we do as a company. And different from many talks that I heard so far at this conference, we are I want to give you a perspective of our really hands in the dirt practical experience in research and what our perspective on the challenges of FDOs are. So I want you to imagine for a second a very simple case. The situation where there's a researcher that has a spreadsheet and some parameter file. So to make it fair and eventually a fair object, it needs metadata. So who is adding this metadata? Anyone? The researcher, yeah. I mean, of course, we all envision probably that as much as possible will be automated at some point, but nowadays it's the researcher. And I think parts of it will never be possible to automate, so the researcher will be always involved. What's the incentive for the researcher to do this?
That this data is understood by others?
Okay, yeah, that's a very good incentive, but very far away. And so I would argue that there are few incentives, and pessimistic people might answer there are even none. And what tools does the researcher have to assist with this job of adding the metadata, then later on managing it, until he reaches the publication in these nice data repositories that we heard before of? So my experience is very little. There's sometimes a file server and a rough structure on how to place data there, but that's basically it in many cases. And if we look at the research data lifecycle, you all know this. We have some experiments, field experiments, whatever, maybe simulations, analysis, data publication, hopefully, and then it kind of starts over. So there are many challenges that come along at managing research data in this process. If you do research for a couple of years, you might at a later point want to access some data set and ask yourself, oh, well, where is that data set? You might find a plot that you did before and ask yourself, on what data is this based on? And if there's a new instrument that is added, if the way data is acquired changes, this kind of needs to be documented, needs to be managed. So lots of challenges, and with our research data management software, we try to address this. We try to reduce the challenges for researchers in the scope, so after data acquisition, and to promote data publication in the end. And what I want to show you today is how when we at IndyScale envision how what our tool provides can make FDOs more accessible for the individual researcher, how to reduce the challenge that I just talked about, that there's a big workload right now for researchers and little incentives. So I cannot go into too much detail about the software itself, but the key aspects would be, are you looking for data? Well, LinkAhead provides a powerful and yet easy search to look into the data that you have. Are you missing metadata? Well, this shouldn't occur if you use LinkAhead because it directly connects metadata and data. And you might have had trouble understanding your data or other data before. And LinkAhead makes sure that the data is kept in its original context, so understanding it at a later point is easy. And if something changes, for example, you have a new device that is acquiring data that you didn't have before, then you can adjust the data model yourself as a user. You don't need an IT department to do that. So automation is key in many research areas because data, the amount of data is just too big to do it all manually. Also, automation can reduce errors because repetitive error-prone tasks are removed. So LinkAhead, for example, provides APIs to do this automation. It allows you to start with little effort to use standard modules that are available, but it's also highly customizable. So if you build your own format, you shouldn't, but if you did anyways, this can also be read into LinkAhead because you can customize it in a way. And LinkAhead can be integrated into existing workflows. One example is Jupyter. So we don't want to reinvent analysis tools. Every research area has their own tools, and it's fine that way, but these tools should be able to continue to be used. And one example is Jupyter with a Python client where you can directly access the data and analyze it as before. So how does LinkAhead facilitate FDOs? So first of all, I said in the beginning, currently there's a big workload and little incentives. So automation is one key to reduce the workload for researchers to acquire or to collect the required metadata. And then having a data model that has the needed metadata in it makes it possible or makes it easier for researchers to acquire the metadata as soon as possible, right after data acquisition and not just before the data publication when this is a big hassle. Then using our software provides for a research group a standard way to collect the metadata. It's not every researcher that has to come up with his own solution, but there's just a standard way for a research group to do this that they can agree on, and then not everyone has to think about it him or herself. And once the metadata is integrated, it actually provides a benefit. And this is something that we also will continue to work on. The key point is that there have to be benefits for the individual researchers, otherwise they won't do it. And first of all, I think most people would agree it's just nice if you can look at complete data sets, not in JSON format, please, but in a nice way you can look at the data sets. It's just all there. It's just fine and complete. You have clarity. You can see what data did I already collect, what is there. And the most important point is the last one, findability. So the researchers can actually search more easily for their data when they integrated the metadata. They can use all the metadata aspects to search for the data in a nice and easy way. So this, I think, is a clear benefit that we already provide. As I said, I cannot go into much detail due to the time limits. There's an interactive online demo where you can try out the software and where we have a tour that guides through the concepts that we have. That is demo.indyscale.com, and more about us and the software on indyscale.com. So an outlook to summarize where we stand with regard to FDOs would be we already have metadata and metadata schemas, and we combine those with the research data into digital objects. And those objects in our software are interconnected. So this already sounds fairly similar. So what we are missing right now is a close integration of PIDs. So you can, of course, connect PIDs to the objects, but to have the possibility to, for example, automatically get a PID for an object in LinkAhead would be a nice addition. And the other aspect that I would mention is that you have the metadata schema, but can you automatically import an existing one? Not yet. And can you compare the ones that you have to existing ones? This would also be a nice step into the, I hope, right direction. And this brings me to the summary. So LinkAhead is fully open source. It provides powerful search options. It can be easily extended. It integrates into workflows. It does not replace existing workflows. And yeah, it stores semantic links among the data. And I would argue it allows you to make your data FDO ready as soon as possible. Thank you very much.
Thank you very much. So just a quick question. How do you link this to vocabularies? Because we had seen it's a really challenging question. So you will have your own terminology, probably, but can you link to the wild world of vocabularies out there, or terminology?
Yes, so you can, of course, introduce dumb links like URIs to the vocabulary. And our approach currently is to reuse the vocabulary that exists in the data model that you have in LinkAhead. But as I mentioned, there is no automated connection so far.
Other questions?
Maybe a comment. So from another Max Planck Institute, you have to make tricks to get the researchers sometimes to create metadata. So what we found out, of course, and you know the same, researchers have a chaos on their machine, on the servers. It's a chaos. And after 3 months, they don't know anymore what versions is where and what did they use. So what our trick was, one of our trick was to help to create an organization tool. And that was the breakthrough that people started creating metadata, helping them organize their chaos.
And I would understand LinkAhead as such an organization tool. Sure. Okay, thank you very much.
You can give it.
Yeah. Okay, so.
10 minutes only, sorry. But
oh, I'll try to make it short. Looking at you.
No, we can also extend it, I hope.
So, am I there? Yes. So I can be short on a few slides since you heard a lot about FDOs. So let me say that we are working together here with a large industry consortium called Industry 4.0. Some of you may have heard that. It's a large industrial consortium in Europe, and they're working based on a huge reference architecture and pinning it down to services and schemas and so forth. So we are working together with them, and what I show you is, how these the way they are doing compares with FDO. You will see it. So the overall goal is, of course, have an integration space. So we always look, and as you have seen it, we always look at TCP/IP. Is there something similar in the world of data? We believe yes, DOIP. We have to make a stress test on DOIP. We're not there yet to say, well, it's doing what we want, but it's a stress test which we have to do. The basic thing is, when you listen to Bob Kahn, the basic thing was when they started with the internet was to understand to do packet switching. And packet switching means you have to define the core data model, which is the datagram. That was the core, basically. And then it was easy for them to write something like TCP/IP. So FDO is a core model in our belief. So we can write something like an integrated protocol. So that's the basis. What we now want to do is, so we have several islands. You heard from Rainer about an island. We have island in GWDG, all working on FDOs. What we want now in Germany is to create a bigger testbed. So bringing together several or more repositories, and that's the purpose of what we are doing. And that has to include, of course, industry people, as you will see. So this is something which is documented somewhere on the web, which we did some time ago. So we created a with help of DOIP, an integration between two completely different repositories. One is B2Share. It's based on Invenio, which is also used by our folks in I forgot, Rainer, you mentioned that, the software, Zenodo, thank you, yes. So it's the same software, it's just a bit different. And so it's a well-designed repository system. It has a PID, it has metadata and so forth. So you know what you can find. So it's not one of, Rainer, of these databases which maybe don't have any structure, or so then you are lost. Yes, so we have B2Share, and there's a couple of instances in Europe, so having one proxy, you easily can, of course, connect the others. So we did this kind of connection, and I will not go into details here. It was basically less than 1 week of programming to hook these two machines together. So Cordra is a repository system, if you want, designed by Bob Kahn's group. So less than 1 week, I have to admit, it was a very good programmer who did this. Now, let me turn then to, well, you know this game, that's the FDO anatomy. So I don't have to repeat this. You have seen these kind of slides frequently. Let me now go to the asset administration shell, as they call it, in Industry 4.0, which is has basically the same function as the FDO. What is the difference? So you have metadata, and they're working on a nice structured metadata set, so with components, right? So you can add components, and they're working hard on defining the categories which are used in these components partly. Of course, an open game. So they do a lot here in this area, and they have standardization bodies doing this in industry, so that, you know, for every kind of machine they're creating, they define what are the parameters and so forth. So it's really a huge investment. And if you look to something like what they are doing, you see documents of 600, 800 pages full of schemas for different machines. So that's what they are doing. Metadata is there. Then they give an ID. I will not talk about whether these IDs are good or bad. They give an ID. The problem is with their IDs, they're using IRIS or URIs, international URIs. The problem is, of course, the difference with what Rainer, for example, showed is these IDs are under their own, administration. I will come back to this point. And and you heard these stories now frequently, we do binding with landing pages or with the records of PIDs. They're doing this by defining a registry, well-defined schema, so you can do quite a number of stuff. You can protect the links and so forth and so forth. So, but they have a registry. The difference is, if you look, if you compare this, these two things are in the, in the control of the owner of the machine. Well, if the machine doesn't have a value anymore in industrial, well, you don't know whether this still exists. They will stop services, since, you know, they maintain this, and that's one of the difference to FDOs. So not to blame them. I think for their case studies, it's about machines. It might work. But you see a clear difference in responsibility and accountability. That's basically a huge difference. So to move on, but you see the similarity of the structures, right? Very simple. There's an ID, there's a binding, and of course there's metadata, and the binding also points to metadata and whatever you have as resources. So the same kind of stuff, which is nice. So we're discussing with them and want to implement this now. So Monday is our next meeting. We're discussing how to integrate these things. And of course, this AIS shell is made for machines, basically. It's the origin. But it could be used for any other type of asset. It could be used for a piece of data on their machine. And for sure, many of the people in industry who understand this machinery will use it for data, for sure. Well, it's if you have the experts who know how to use that machinery, they will use it. So we should be able to integrate it into the data space. So we're working on a connection, and I think you can immediately see that DUIP is a huge tool to do this, since we can ask for the metadata, we can ask for the ID, transform it somehow, we can ask for the pass, and so forth. So it's easy to do, so we have to do it. So this is what I wanted to show you. Of course, we will also try to add something like have an adapter for things like DSpace or Fedora or so for other type of repository systems which are widely used. So the intention is really to get some money for having a larger testbed and do a stress test for DOIP. Thank you very much for your attention. I hope I'm in time.
Yeah, perfect. Peter, you could keep the time constraints. So we have still 1 or 2 questions that we can answer. Is there anybody? You mentioned industry.
Yep.
So what's the link to industry? Is that...
Well, for us, for some of us, it's clear, sorry. For some of us, it's clear FDOs will only make it if industry buys in. Very frank. And industry expects clear specifications, standards, and that's what we are doing. So you have maybe heard that we are working together with DIN, which is the German ISO, if I may say, together with DIN to create standards, and they are pushed by industry. And we have a lot of interaction now with German industry, so with the big guys, Siemens, Mercedes-Benz, and God knows what. And they're all sitting in these meetings where we are now introducing FDOs. And I think we have now 6 meetings, have had 6 meetings in the last months. And at the beginning, when I gave my first talk, of course you had, who is that? What's that? You clearly see that, of course, the industry also gets a lot of money at this moment. Some of you have heard about Gaia X and so forth. These are the kind of people sitting there. And industry gets a lot of money currently. And what this lot of money does is creating this, I guess you were there yesterday, creating this serialization, as we call it. You know, you give some engineers, good, smart engineers, I am one of them, you give them some money and they will find another solution. Tomorrow you have another, branch in the evolutionary tree. So that's what the industry sees at this moment. They see this huge fragmentation, and that costs them huge amount of money. And now we are so that they start, the toppers, that they start interacting with us and say, do you think that there is a convergence? And we, of course, say yes. They don't believe yet fully, but we're hammering on them.
So, thank you very much also for your...
you
have still a question, yes.
If this is on. I want to bring up that link you mentioned with B2Share and Zenodo. I think that's an important aspect of bringing in kind of legacy systems, because you have kind of lots of data that is kind of trapped inside an archive that is maybe in specific file formats and so on. But I wonder, what are your thoughts on what this implies in terms of identifiers, in that you're making basically a digital twin of an existing digital object? And is that a proxy for the object, or is it the same identifier again in a different view, or what do you think about that?
Yeah. So as I've shown, they use their own identifiers, which are, maintained by the machine producer. Well, so we didn't do it yet, so we're having Monday our next discussion, and we will start implementing them soon. But the intention certainly is, if we transfer to the FDO domain, at this moment, we will just create a handle, and of course store the identifier they are using, right? So to have a link back. What they want, the Industry 4.0, there's a bit of competition. Competition is good. They want to, of course, show that Industry 4.0 can harvest all the other data. Well, I'm curious how this will work, but they want to show it as well. So yes, the identifier is an issue. We will create handles very clearly, and we have to maintain their their identifiers they are using. So if you go back, there is a link and so on.
And I think it's important that there's a two-way link, right?
Yeah,
So you
yeah,
can also
yeah, yeah.
find the FDO from the classical object.
Yeah. And you are right, Stian, of course. There's so much out there. FDO IP doesn't work with different systems, well-structured repository system, let me say, well-structured. We have seen a lot. Then it would not be useful. Since there's so much out there, we have to adapt them. We cannot expect that they change. No.